Hey guys, Mr. Isley here. So we're on to lesson number 24 in chapter 4, all about writing linear functions. And so in lesson number 24, we're going to talk specifically about writing arithmetic sequences. And we're going to talk about them as writing them as functions as well, and how does that all work. We've been looking at an arithmetic sequence and identifying them, whether they are or aren't, what's happening within them, but how do we actually write them ourselves? And I don't mean just writing the numbers, but how do we figure out, if we were given the first 4 terms, how do we figure out what the 105th term is without having to list out every single term in between? So what we want to talk about this and what we need to understand is because consecutive terms, right? First term to second term of an arithmetic sequence have a common difference, right? Meaning that they increase or decrease by the same amount every single time. So from the first term to the second term, that increase or decrease is the same as it is from the second to the third, and from the third to the fourth, and so on and so forth. So because they have consecutive terms have a common difference in an arithmetic sequence, this has a constant rate of change. And I kept mentioning that in earlier lessons, this constant rate of change. We learned about this in chapter 3, right? How to identify it, all of that. It's the same idea in arithmetic sequences, right? So because this idea of common difference and constant rate of change are very, very similar, right? This means points in the sequence would fall on a line, or they would be linear. And we saw that when we were looking at graphs or graphing arithmetic sequence. They looked like lines, right? There wasn't a line drawn through them, but the points went in a linear direction, constantly changing at the same rate. So we noticed that points in the sequence would fall on a line if we drew them through. They're linear, right? We can then use that information, because we know that, to write a linear function, right? We can write a linear function of an arithmetic sequence because all the points are going to fall on that same idea. Now, here's a chart that's in your book, and I just want to point out a couple of things on this, right? It's kind of a simple way to figure out what is going on in an arithmetic sequence. So we talked about this idea of position in where it is in the sequence, so first term, second term, third term, so on and so forth, right? We also talked about this A of n, so the actual term itself, so the first term, the second term, the third term, for what are the numbers actually? Well, because we are given this information, we can actually figure something out, right? And that is that the first term, we call that A of 1, right? Its position is A of 1, right? We know what that number is, right? Then when we look at, we can actually figure out the second term as long as we know what the common difference is. And that's what this D stands for, is it's saying that this is the common difference. And what we're saying is that if we know the first term here, we can add the common difference and figure out the second term, right? Same idea here, is if we know the first term, we can add the first term and then multiply the common difference by 2 and figure out the third term. So on and so forth, all the way down the line. Now, a lot of times they'll give you like the first 4 terms in a sequence, but then they're like, hey, what's the 123rd term in this sequence? Well, it will take you a while to write out the 5th term, the 6th term, the 7th term, the 8th term, the 9th term, the 10th term, all the way to that 100 and so many that you need to figure out. So what we've actually determined is there is a way of going about this, a formula essentially, that we can plug information into and we can figure out what it is. If we know that an arithmetic sequence is happening, as long as we know the first term in that arithmetic sequence, right? So A of 1 is what we call that first term. As long as we know that, right? Then, and we also know the common difference, so the D, right? We can figure out whatever term it is we want. So if they tell us that, hey, it's the 105th term, we can plug that into this spot right here in this formula and determine anything we want, right? So just for example, to give you a quick little example, if they said, hey, your first term in an arithmetic sequence is 6, all right? So first term is 6. And the common difference, right? The common difference is 2, all right? So it's a positive 2, is 2. Tell me the 110th term. So they've said, hey, 110th term. All right, well, it would take us a while to start from this first term and get all the way to the 110th. But we could take those three pieces of information and plug them into this formula to figure it out. So my first term was 6, so it would go right there. So I would say 6, make sure this is on the paper, yep. And then plus parentheses n, that's the term we're trying to figure out, which we said was the 110th. So 110 minus 1. All right, because we need to subtract 1 off from the original term that we had here, all right, times the common difference, which was 2. And we could figure out that term, all right? Now, I'm not going to do that right here. We'll do that in a later lesson, but that would be how we would plug that information in. And we could figure out any term in an arithmetic sequence as long as we know the first term in the sequence, the common difference, and as well as what term it is that they want us to figure out. All right, well, just one other piece of information that I wanted to talk about. I just gave you this idea of this formula. So A of n is going to be equal to A of 1 plus n minus 1 times the common difference, which we call D. Right? A of n just means the positions term. So we would say, if again using the example I gave you, 110th, we would say A of 110. All right, that's all we're saying there. All right, A of 110, and I apologize, this should actually stay as n, because we could solve this for n. All right, so I messed that up. So what we were saying here is A of 110, right? And we're solving it for n. We would figure out what n was, which would tell us the actual number of it. All right, but the position was 110, as we mentioned. All right, from there, we can also say this function. All right, so we can replace A of n, which is an arithmetic sequence, to write this function of an arithmetic sequence. And so we're just saying f of n. So really the only difference between those two things are the A of n and the f of n, and they mean the exact same thing. All right, well, I know I kind of messed up a little bit right here. I told you something that went in there wrong. We'll put this into motion here in a little bit in this next lesson, lesson number 25. So if you're a little confused at the moment, I apologize. But we'll get this all figured out when we do these examples. It'll become much more clear. But this is just some information that you need to know. So big things I want you to derive from this, right, is that you need the first term of an arithmetic sequence and the common difference, and you can figure out any term in there. Despite that, no matter how far down the line it is. And then please make sure you've highlighted these formulas. This A of n, right, which stands for an arithmetic sequence, and then the function version of it, f of n right here. Those are really important. All right, well, if you have any additional questions before the examples, please let me know, but otherwise continue on in the chapter.